Good morning, this is your Stat Sensei, and this is Mr. Sensei, and this is a warm-up for computer printouts for regression. So the very first thing you have to determine when you see this large blob is where to go. And where to go is to look for the word constant. Once you find the word constant, you can highlight that entire row because that row represents the y-intercept row. Everything on that row is related to the y-intercept. And then below it, and it's always below it, it might be, who knows where constant's going to be, but below the constant row is the slope row. All right. And most everything we're going to need, not everything, but most everything we're going to need for this course is going to be on one of these two rows. All right. So our first question is to ask for the explanatory variable. Well, explanatory is the x. All right, I see X there, and that makes me go, oh, this is going to be an X. And my X variable is always directly below the word constant. So in this case, our X variable is average temp. So that's letter A. The next thing it asks for is y-intercept. Well, guess what? Y-intercept is on the y-intercept line. And our y-intercept is always next to the word constant. So in this case, our y-intercept is 35.67806. Then it asks for slope. Well, not surprisingly, slope is going to be on the slope row, and it happens to be right below our y-intercept. And in this case, it is negative. And so please note that slope can be negative, meaning you can have a downward facing slope. The next thing it asks for is the regression equation. Well, the regression equation isn't specifically on there written out, but we have all the information already. And it's based on what we learned in Algebra 1, y equals mx plus b, but we're going to change it up a little bit. So in Algebra 1, b was our y-intercept, and m is our slope. But we're going to change the order um, for statistics, and we're going to go with y hat equals our y-intercept plus mx, where b is still our y-intercept. Now this changes on the calculator, but this is the order we're going to write it in, and m is our slope. So in this case, we're just going to start off with the y hat because that's what we need, equals, well, our constant is 35.67806. I'm going to shorten that up to just two decimal places. So 35.67, that's our y-intercept. And then we need our slope. Well, it says plus, but really we have a minus here. So make sure you capture that minus sign. So minus 0.0777, and then we'll put an X at the end. All right. And this minus 7.077 happens to be our slope. The next thing it asks for is standard deviation of residuals. All right. Now, the standard deviation of the residuals, it doesn't say. Now, sometimes this gets confusing because this sometimes says standard deviation, but this would be standard deviation of the slope. And the key word here is residuals. All right. So our standard deviation of the residuals is in a different location, and it's just labeled with a big old S. So our standard deviation of our residuals in this case is 1.3192, and it's right over here, and you just have to hunt around for the big S. The big S floats around, but anytime you see the big S, it's standard deviation of the residuals, which is 1.3192. And I'm going to go ahead and highlight that whole thing in orange. All right. The next thing, I asked for the t statistic for slope. And by the way, I see slope on the next two words. So, hey, you know what? This was supposed to be on the slope row. So, looking on the slope row, I look for t statistic. Oh, I see two t statistics, but the one that I want is the one on the slope row. So this becomes negative 10.22. I should put an E by this. And I should put a C by that. And then the t statistic is F. The next thing it asks for is the p-value of the slope. Well, this is our p-value. We have two of them, but it said for the slope, so we want it off the slope row, which is 0.0113, and that is G. The last thing it asks for is the correlation coefficient. I'm going to highlight that in orange. It's not actually on the formula chart. I mean, it's not actually in the computer printout, but we have the information that we need. What we're going to need is the sine of the slope and the square root of r squared. All right, so when I look, I see, oh, I have an r squared here. I also have an r squared here. The question is which one? Well, it's easy. The word adjusted or ADJ, we will never use in this class. All right. It is used in statistics, but we're not going to use it. So we're going to take the square root of 48.96. But before I do that, I need to turn it into a decimal. And remember to do that, we always put percents every single time, always put it over 100. So we're going to take 48.96 and divide it by 100. And we get 0.4896. All right. And we need to take the square root of 0.4896. So I'm going to do that. I do that by raising it to the half power. You can use the square root sign if you want. Raise it to the 0.5, and we get 0.6997. So now we have our r squared of 0.6997. But we're not finished. We forgot a part. We need the sine of the slope. Well, the sine of the slope in this case, when we go up and look at the slope, oh, our slope is negative, so we need a negative sign right there. Okay? So that's how you get your correlation coefficient, not directly on there. You're going to have to take the square root of r squared and pay very careful attention. If it's a positive slope, then this is a positive. If it's a negative slope, this will be a negative. All right, I appreciate you watching. Look forward to seeing you on the next one. Thank you.